Gold, the shimmering metal of legends, has enchanted humanity for thousands of years. Its rarity, beauty, and unique physical properties make it one of the most sought-after materials on Earth. Whether adorning crowns, driving economies, or enabling cutting-edge technologies, gold's appeal is universal and timeless. Unlike other metals, gold resists tarnishing, retains its luster indefinitely, and is extraordinarily malleable, capable of being stretched into wire thinner than a human hair. These traits, coupled with its scarcity, give gold its unmatched value. But what makes gold truly extraordinary is the painstaking journey it takes to reach its final form. Extracted from deep within the earth, this journey is a testament to human ingenuity and perseverance. The journey of gold begins deep within the earth, where gold-bearing ore lies hidden in layers of rock. Mining operations involve carefully planned processes that use massive machinery to extract these valuable deposits. Depending on the location, mining is conducted either through open-pit mining or underground mining, with each method requiring specific techniques and equipment. In open-pit mining, the process starts with clearing the overburdened layers of soil and rock covering the gold deposit. Bulldozers and excavators strip away this material to expose the ore. Once the deposit is accessible, large rotary drills are brought in to create deep, precise holes for blasting. Explosives are inserted into these holes and detonated, breaking the rock into manageable fragments. Underground mining, by contrast, involves creating tunnels and shafts to reach gold veins buried deep below the surface. Miners descend using elevators or conveyor systems, working in confined but meticulously planned environments. Here, specialized drills are used to create blast holes, and smaller controlled explosions are performed to minimize damage to surrounding areas while loosening the ore. Once the rock is fragmented, heavy-duty loaders scoop up the broken material and load it into massive haul trucks. These trucks, capable of carrying hundreds of tons in a single load, transport the ore to crushing stations located either on-site or at nearby processing facilities. For underground mines, mucking machines, similar to loaders but designed for confined spaces, are used to gather the broken ore and load it into mine carts, which are then winched or transported to the surface via conveyor systems. The logistics of transporting ore from deep underground or rugged open pits are impressive. Once the ore is brought to the surface, the process of liberating gold begins. The first stage involves crushing the ore into smaller, manageable pieces. Large crushers break the ore into chunks the size of gravel. Following this, the crushed ore enters the grinding phase. This step is crucial and performed in ball mills, large cylindrical drums filled with steel balls. These heavy steel spheres tumble alongside the ore as the drum rotates, pulverizing it into a fine, sand-like powder. The continuous impact of the steel balls ensures even the hardest rocks are ground down, exposing the gold particles hidden within. Ball mills are a marvel of engineering, combining strength and precision. They are lined with materials like rubber or manganese steel to withstand the abrasive nature of the ore and to maintain efficiency over time. The grinding process can be fine-tuned by adjusting the rotation speed, the size of the steel balls, and the duration of milling. This grinding phase not only increases the surface area of the gold-bearing particles, but also ensures the ore is ready for the next step: chemical extraction. By the end of this process, the material is reduced to a texture resembling fine beach sand. Once the gold-bearing ore is finely ground, it enters the extraction phase, where the goal is to separate gold from other materials. Cyanidation, a chemical process developed in the late 19th century, remains the most efficient and widely used method for gold extraction. The process begins by creating a slurry of finely ground ore, water, and a dilute cyanide solution. This mixture is transferred to large agitation tanks equipped with powerful mixers. The tanks are designed to keep the slurry in constant motion, ensuring the cyanide can react evenly with the gold particles. Oxygen is introduced into the tanks through air injection systems or mechanical aerators. The presence of oxygen is critical as it accelerates the reaction between the cyanide and gold, forming a gold cyanide complex. This chemical reaction dissolves the gold, effectively extracting it from the ore while leaving behind other impurities. The slurry is then moved to a series of filtration tanks to separate the solid waste material from the gold-rich solution. Rotary drum filters, or vacuum filters, are commonly used with fine mesh screens that trap the solid impurities while allowing the liquid to pass through. The resulting liquid, often referred to as pregnant solution, is a cyanide-rich mixture containing dissolved gold. At this stage, the gold is still in liquid form, bound chemically to the cyanide. To recover it, precipitation agents such as zinc dust, activated carbon, or aluminum are added to the solution. These agents react with the dissolved gold, causing it to solidify into tiny particles. The solid gold is then collected, washed to remove residual chemicals, and sent onward for smelting and refining. Throughout the process, meticulous control of pH levels, cyanide concentration, and oxygen levels is essential to maximize efficiency and minimize environmental risks. Safety measures are in place to ensure the cyanide solution is handled and disposed of properly, adhering to strict environmental regulations. Cyanidation transforms what was once a mixture of dirt and rock into a solution rich with one of the Earth's most precious metals. This chemical marvel, paired with precise engineering, ensures the gold's journey continues toward its final gleaming form. Economically, gold remains a cornerstone of global finance. Central banks stockpile it as a reserve asset, and it continues to be a safe haven for investors during times of uncertainty. The metal's ability to retain its value makes it unique in a world of fluctuating currencies and volatile markets. The gold-rich concentrate is now ready for smelting. In this stage, the material is mixed with flux, a combination of silica, borax, and sodium nitrate to aid in separating impurities from the precious metal. The mixture is then heated in a furnace to temperatures exceeding 1,600 degrees Celsius. Inside the furnace, the intense heat causes the gold to melt, while lighter impurities rise to the surface as slag. Workers carefully skim off this slag, ensuring the molten gold beneath remains pure. Once the slag is removed, the molten gold is poured into molds, forming doré bars, gold ingots that are approximately 80% pure. As these bars cool and solidify, a thin layer of slag may remain adhered to their surfaces. Today, gold's allure extends far beyond its historical significance. It plays a crucial role in modern technology and medicine. Gold's unparalleled conductivity and resistance to corrosion make it indispensable in electronics, from smartphones to satellites. It's used in thin films on glass to reflect sunlight in skyscrapers, and even in spacecraft to shield against cosmic radiation. In medicine, gold nanoparticles are revolutionizing treatments for cancer and other diseases, thanks to their biocompatibility and precision targeting. Its use in dentistry, particularly for crowns and fillings, dates back centuries and remains popular due to its durability. To remove this residue, the cooled bars are placed in slag removal machines, which scrape and polish their surfaces. This step not only ensures the gold bars have a cleaner appearance, but also prepares them for further refining. Finally, these doré bars undergo additional refining processes to achieve the international standard of 99.9% purity. Methods like electrolysis or chemical dissolution are used to separate the last traces of impurities, transforming the gold into its most pristine form. Gold is more than a metal, it's a symbol of power, beauty, and immortality. For millennia, it has been woven into the fabric of human culture. Ancient civilizations worshipped it, crafting it into crowns, idols, and jewelry. From the tombs of Egyptian pharaohs to the riches of the Aztec Empire. Established in 2014, African Gold Refinery (AGR) marked a significant milestone for Uganda and the region. As the first initiative of its kind in East Africa, AGR provides transparency and advanced technological capabilities to the gold refining process. With the capacity to refine and produce up to 600 kilograms of high-purity gold kilobars daily, AGR sets a standard for both quality and efficiency. The journey of gold through AGR's facility begins with the remelting of scrap bars. This initial step serves a dual purpose: homogenizing the material and enabling deep sampling to ensure an accurate representation of its composition. Samples from each batch are sent to AGR's geochemical laboratory, which is equipped to deliver comprehensive and certified analyses. The laboratory employs advanced techniques, including fire assay, FA, and inductively coupled plasma, ICP, to test the gold's purity. These precise methods ensure the accuracy of results, providing assurance to both local and regional stakeholders. AGR's laboratory also supports the wider mining industry by offering certified soil sample analyses, enabling miners to better understand their resources. One of AGR's standout technological methods is its use of the Aqua Regia refining process. This chemical procedure, renowned for its effectiveness, dissolves impurities in precious metals to produce gold of exceptional purity. Aqua Regia, a mixture of nitric acid and hydrochloric acid, is a time-tested method capable of refining gold to a purity level of 99.99%. During the process, the gold is dissolved, leaving behind impurities that are separated and disposed of responsibly. The resulting liquid is further processed to recover solid gold, which is then melted and cast into bullion bars.